Welcome to the Shadow Tables tutorial part 2. Now here I've got open a governance database, which is one I developed not that long ago using the Shadow Tables feature, and we're just going to have a little bit of a look at how the Shadow Tables work in here. So first of all, we've got, this is a front end, and we've got linked tables from the back end. I'm going to open them in Design View, and we're just going to have a quick look. Now you'll notice that required yes, Boolean values are required by default in newer versions of Access. Required yes. So you'll notice, okay, and here's a good example of something that probably would have been required no if I hadn't made this rule about non-nullability. It's required yes, but we've assigned it a default value of an empty string. So that allows us to have required fields that don't necessarily have to have any data entered into them in a new record. Here's one that's not required. So again, sometimes we get fields that are genuinely need to be nullable, particularly dates, and that's fine. What we're trying to do is minimize the number of fields that occurs for. So this table looks like it's fairly well constructed as opposed to the Northwind orders table. Now, how do we stop this information from flowing through to the user interface? Well, I'm glad you asked. So we have this thing called a shadow table. Now, it's got the same name as the regular table, except there's an underscore appended at the end of the name. And you'll also notice that this table is a local table rather than a shared one. So this exists in the local database, not the back end. If we look in Design View, you'll see that basically this is an exact copy of the main table, but all of the restrictions have been turned off. Allow zero length is yes for every field. Required is no for every field. In every other way, it's exactly the same. There's a couple of extra fields at the end as well. So you'll notice is new, defaults to true. So this is like a system flag that the Shadow Tables code uses to identify a new record when we've added a new record to the Shadow Table. The primary key and the auto number field is actually the local ID. This means that we can keep track of new records in a Shadow Table without them having had their primary key in the main database assigned. So this might actually be null, but we've still got a good primary key here that we can use to keep track of all these records. And we never assign this. This is just automatically generated when we read and when we add new records or write records into this table. So this is just thrown away every time we delete a record, basically. And there's a validation error field as well, yes or no. This is to help with validation in continuous form. So if you've ever tried to print a message in a continuous form, you'll notice that an unbound message appears for every single row in the unbound form. And the only way to get one to specifically appear for a particular row is to tie it somehow to the underlying data source. So this column here allows the validation code to set a flag to say there's an error in a particular row, and then we can do some formatting perhaps. Perhaps we can turn the background of the row red. There's various tricks we can use to do that with the underlying data. But the prerequisite for all of those is that there has to be some data item we can use as a flag in the underlying data source. And that's what that's for. The initial value as well, there are various strategies when we want to hide foreign key values. So it's called a soft delete. So a lot of the time in a database, rather than deleting a record, we want to mark it as hidden or deleted. That's because historically that foreign key has been used in a record, and we no longer want it to be used for new records, but we still want it to be maintained for old ones. So we'll often have a deleted field. And then it becomes tricky because we don't want to display that value in the combo unless it's already been used. We don't want to display that for new records, but we do want to in the case that the value already exists in a table. So this here is like a copy of the initial value that can be used to maintain that value in the combo, even if this has changed several times. We'll have a demonstration of that in another tutorial. You've seen the shadow table object now. The shadow table library lives in the module section here, XF table shadow. And you may wonder how these tables are actually created. So let's go and have a look at that. So in the this is in the linked table manager, there's a column for has shadow table, and if that's ticked, then we can get the code to automatically create a shadow table copy of the main table for us. And the way we do that, the easiest way is to go Control G for the immediate pane, and then we'll say xf.command. There's a list of commands we can use in the command object there, and then S for shadow table. So shadow tables refresh will just automatically refresh all of the shadow tables in the database. So if the shadow table doesn't exist, it'll be created, and if the shadow table does exist, it'll be replaced. And we need to do this, obviously, because they're copies of each other. Every time we change the back-end schema, we do need to do a refresh of the shadow tables. Otherwise, they get out of sync with each other. But that's probably really the only demand that the shadow tables feature places on you. It's pretty good with all the other stuff. It knows about the database schema. It automatically reads that, so it can provide automatic validation on all the values before they're written to the database. So basically, the form can store any information it likes in the shadow tables because there are no restrictions on the data. And then just before the data needs to be written to the database, we can run some validation code and just check that everything that's there needs to be there before it's written to the back end. If it's not, we print a message and tell the user they need to do something. But if the validation tells us that the data in the shadow tables are fine, then they just get written to the back end. So there's quite a few advantages of this. It gives you complete freedom in the user interface. We can do things like create child records before the parent records are created, because the shadow table feature can link up parent and child, and it'll automatically write a new parent ID into the child records before it saves them. It retains the same familiar forms data binding paradigm that everybody knows, rather than going to an unbound sort of scenario. So obviously it supports the continuous child records, and also we can put in programmatic validation if we like. So because everything is code-based, rather than the magic sort of events that happen when we press a key to create a new record, for example, all of that has to be done in code, which is an advantage if we want to be able to, say, insert some custom validation code at some point in the validation process. It gives us a much greater degree of control over the reading and writing of a form than what we currently do in the native access ways of doing things.